Greetings to all, welcome to the channel Simtech05. In today's video, we will have a look on the amplitudes available with the Abaqus. There we have number of amplitudes in Abaqus, but few of them we use very frequently and few we use occasionally. And what I found, if you want to perform dynamic analysis, this amplitude play a very important role. Of course, in general static step also they play important role. In other steps also they play important role. Like if you want to perform the frequency response analysis, random response analysis, then also these amplitude play very important role. Surely, but what I found, there is lack of explanation on these amplitude. So I will try to cover these all amplitude definition within one video. This may be helpful to understand the different amplitudes and applications. So start with the basic one, the tabular one, amplitude one, and very easily by defining x and y parameter you can define such tabular amplitude. Here is the second example and here is the third example. More number of parameter will give you more accurate tabular amplitude form. But here we have one problem. If you look the first amplitude and second amplitude precisely, in the first amplitude at the time of 0 we have two values, like at time of 0 you have 0 magnitude, and again suddenly you want to apply the magnitude, or we can say suddenly at time of 0 you want to apply the magnitude 1, and this break the law of monotonic. Two values like two amplitude are there at the same time. So in this way you cannot define the amplitude tabular form. So what you have to do, you have to keep at least some gap between these two value in the x parameter, or we can say the difference in the time. Like here we have 0, then 0.05 second, maybe 0.0005 second. So in this way you have to define some gap. Let me show in the software. So I believe you remember this problem in dynamic playlist, the second video. With the help of this problem, I talked about the equilibrium in the dynamic and static system, as well as in the first video also of the playlist I took the same example. There we learn about the loading conditions, like when we consider one load as a dynamic and static, we perform the simulation using general static and implicit and explicit step and compare the results. So there we define the amplitude. Of course, that was not a tabular form amplitude, that was something different. But here I'm going to delete the existing amplitude and creating one amplitude tabular form. Create and say, to easily assess the data that available in the PPT, I copied in Excel form, and let me assess from there. So here we have, in this data I want to copy, so let me copy, paste, and OK. See, amplitude is defined, and if you want to plot that amplitude, just go here, plugins, tools, and amplitude plotter. Make sure you are in the load module. Okay, if you are in the property module or somewhere else, likewise this plugin and tool and amplitude plotter options will not available. So make sure you are in the load module, then go to the plugins, tools, and amplitude plotter, and now click on plot. See, this will give you one error message, float division by 0. Why? Because as I explained, let me move on the Excel. As I explained, at the same time of 0, or we can say at the time of 0, we have two values of the magnitude. So using this amplitude definition, tabular form, we cannot generate such curve. We have to define some gap between the two values, time gap between two values, two amplitudes. Okay, so can I do this? Yes, of course you can. Just copy it and just make it clear. Of course you can directly paste it, but for safe side I'm going to clear it, paste it, and like click on plot. So this is my amplitude. Similarly, I'm going to copy this amplitude data and let me create one more amplitude, amplitude 2 tabular form, and let paste, click on OK, and let place plot it. So you may found one difference. See, similarly in the first amplitude also you have one problem, that yellow color is not visible. Just plot it again. See, the corners are not sharp as we can see in the Excel format here. And same for the second tabular amplitude. Here also by default we got some smoothness on the curve. This is due to default nature of the tabular amplitude. What is that default nature? See, by default here the smoothing options is checked on and solver default is used. So if you want to define the manual smoothing, like I don't want any smoothing, simply click on 0, or what I can do, I'm going to cancel it and let make a copy of the amplitude 2. So here I'm going to specify the 0 smoothing, copy, not copy, okay, we already copied. Go to the plugins, tools, and amplitude plotter. Let's plot these two amplitude. Click on plot. Now you can see the difference. Let me zoom in. Now you can see this one, this rounded one, smooth curve one is amplitude 2, and this sharp curve without any smoothing, that is the amplitude 2 copy that we defined without any smoothing. Of course you can manually control that smoothing value, like 0.1 you can define or some other value. Up to 0.5 we can define. Okay, so let plot again and you will get a smoothing in the second curve also, but with the smoothing value of the 0.1. You cannot define the value beyond the 0.5, like 0.6 I want to try, click on OK, it will show you the error message. So smoothing is expected between 0 and 0.5. So this is all about the first amplitude, that is very easy, tabular form. If you have curvature type of amplitude, you need to define the more number of parameter to get a better amplitude, or we can say precise amplitude. One more thing here we have to understand the time span. So the time span is step time or total time. It's mean if you have step time of 1 second, or we can say step time of any time, so this amplitude will be only for the current available step. Or if you create here the total time, what it's mean, like if you have first step of 2 second, then second step of 3 second, so load will be distribute in the first step and second step in the both step from the 0 to 5 second. The total time is now, event time is now 5 second, the first step time is 2 seconds, second step time is 3 seconds, so total time is 5 seconds, and here also we have total time as 5 seconds. But you have such case like step time, I mean to say step 1 only take 5 seconds to complete, so you can define in such way. And for the another step you want to define the another amplitude. Okay, so this is the total time or step time. So I believe you are well aware to the amplitude, and let's say tabular form, and switch on the PPT again. Okay, so we seen what we can feed and what we cannot. Of course, these type of curves also you can feed, but not in the tabular. You have to go with the user one. Let me highlight the marker. Okay, so time span we seen, curve smoothing we seen. Next one is equally spaced amplitude. That is the very simplest one. Here, as we can see, whatever load you will define or whatever displacement you will define, that will simply vary linearly over the time period. So this is nothing but your equally spaced, means whatever load or displacement or anything you have, that will be equally distributed over the time period. Let me switch on the software and I'm going to delete these two amplitude and amplitude 2 equally spaced, and see here in tab you have only two values like time from 0 to 1 and amplitude. Say if you have interval of 5 seconds, then 5, and here you will get automatically 5 seconds. No need to define the intermediate value, only you have to define the first amplitude. Say at time of 0 I have amplitude of 0, at time of 5 seconds I have full amplitude or amplitude 1. Okay, not this one. I'm going to delete this. Okay, and now click on OK. So this value is de-highlighted. You cannot edit it manually. You have to define your fixed interval and click on OK. Amplitude 2, let me plot, plugin and tools, amplitude plotter, click on plot. So the amplitude or whatever load with respect to amplitude is assigned will distribute linearly over the time period. You may think, sir, why we need such this amplitude? Of course, in the general static step, whatever load we define, by default it will linearly applied, or we can say ramp type of loading we have in the general static step. But when we talk about the dynamic type of loading, say implicit case, say explicit case, the load is applied instantaneously. Okay, but if you want to apply that load linearly over the time period, you can utilize this amplitude. Can we utilize the first amplitude? Say this one, this tabular one. Of course, this tabular one also you can apply or you can utilize, like amplitude, and at time period of 0 I have amplitude 0, at time period of 5 seconds I have amplitude of 1, and now click on OK. Then again go to the tool, plugins, tools and amplitude plotter, and you can see both. Okay, they must be same type if you want to plot the both. So this amplitude 3, click on plot, see, and in the same way you have this plot. So there is no difference, but here we have one more facility in equally spaced amplitude. Say the fixed interval of 5 seconds you have. At the time of 0, the amplitude 0, at time of 5 you have amplitude 1, but after again the 5 second of the interval, your amplitude become maybe 0.5, and again after 5 second, when you press on the enter, automatically this value will be considered. You cannot edit this value. Okay, and this become 2. Now click on OK and try to plot it. This amplitude 4, plugin, tool, amplitude plotter, and just click on plot. Of course we have smoothing, so let me remove the smoothing as 0, click on OK, plot. So likewise from 0 to, let me edit it, from 0 to 5 seconds this load will be vary from 0 to 1 linearly over the time period of 5. Then after, for the next time period from 5 to 10 seconds, the load become, the amplitude become again reduces. So over the time it reduces and again over the time it is going to reduce. So you need to exercise less here compared to the tabular form if you have fixed interval. Okay, make sure you have fixed interval. If you have variable interval, then you can utilize the first type of amplitude. So the next one is periodic. That is the most important one, and people always suffer with this. I will try to explain its mathematic background as well as how to define the periodic amplitude properly. So let me move again on the PPT. Okay, so here we have number of plots, and you can define such plots using the periodic. Periodic means the force or the amplitude or the displacement itself repeating after some time period. Okay, so this is the function to define the periodic amplitude. It may look like very difficult initially, but don't worry, it is very easy to understand. Okay, here we have two conditions. If time period is less than t0, okay, generally what happen, we start from the 0, but sometimes you have to start from 0, not from 0 but from the 1 second. If the time period is greater than and equal to 1 second, then this formula will be applicable, and before that this formula will be applicable. Okay, what it's mean, let me show you in the abacus. Periodic, do not worry much about the other parameters I'm going to define. Okay, so the period is 2 pi, and starting time is 1 second. Okay, and initial amplitude is, again initial amplitude somewhat 2, and the b value is going to define 1, and now click on OK. Sorry, here we have to define a as 0. Why I'm going to define a 0 b1, I will explain. So go to the plugin tool, amplitude plotter, amplitude 5, that is periodic, and this one. So what I mean to say, see, when time equal to less than t0, and what is t0 here for our case? In our case, the t0 starting time is 1. Before that, amplitude will be considered as a value of a naught. And what is the value of a naught here? This is the initial amplitude 2. And after this time, see, after this time t0, here we have t0 value. This is starting time. This become a function of sine and cos, and accordingly whatever value I defined, accordingly it will start plotting. Okay, so this is my initial time t0, or we can say beginning time t0. Before that my amplitude become a naught, after that my amplitude become as per the formula, or amplitude not become, will consider as per this formula. So what if you want to define only a cos function? You don't want to define this particular value. Okay, I'm sorry, this particular this value. So simply in this formula, if you feed b equal to 0, this term will be completely 0, and assume the initial amplitude a naught is 0. So what only you will have? You will have only an cos n omega theta. Okay, I'm saying t minus t naught as theta. So this will be simply a cos theta. And if you want to define the sine curve, how you can define the sine curve? Just pause the video and think. Of course, by putting the an value as 0, so this term will be 0. A naught is already we considered 0, and this become a bn sine n omega t minus t naught. Okay, so in this way you can define the sine plot and cos plot. Let me explain in the abacus. So I'm going to close it. I'm going to delete the all previous amplitudes. Yeah, that's fine. And this is my amplitude plotter. Let's double click on the amplitude periodic one and click on continue. Okay, let me define the proper name. So you want to define the sine function. Click on continue, As I told, here A and B, see, A is dedicated for the cos and B is dedicated for the sine. And what you want to define? You want to define the sine function. So in the sine function, A you have to define some value like 1, 2, 3, it's depend, and B you have to define 0. Because you want to make sine function, oh I'm sorry, this is the sine one. A you have to define 0 and B you have to define 1. Okay. Starting time. Do you want to define some starting time? No, I don't want to define any starting time. Earlier we defined. Do you want to define any initial amplitude? No. I am going to keep it 0. The circular frequency, that is the most important part. The circular frequency, and I will try to explain it. See, this plot is for 1 second only. Okay, whatever circular frequency you will define, it should be for the 1 second. So in 1 second, I want to complete one cycle, and the circular frequency you have to define to complete one cycle is 2 pi. So of course you can feed the value of 2 pi, or you can simply 2 cross pi. You can type this 2 pi and click on OK. And let's plot. So this will be the sine plot, and you can see in the 1 second, here this is the 1 second, in the 1 second it will complete one cycle, or I'm going to rename it sine, and the frequency is 2 pi. Okay, let me plot it again with some different frequency. I'm going to copy it. Instead of 2 pi, I'm going to define 4 pi. This is the only name, okay? 4 pi. And let me define the frequency 4 pi. Means within 1 second, I want to complete 2 cycles. So 4 into pi. And click on OK. So now we have 2 amplitude, and let's plot these 2 amplitude together. And now you can see the difference. How beautifully software able to create 2 cycle within the 1 second. See, the earlier the green graph, green plot having only 1 cycle within the time period of 1 second. But the second plot, that is the sine 4 pi plot, in the 1 second it going to be complete 2 cycle, one cycle in the 0.5 second and another cycle in the another 0.5 second. So in the total 1 second, the 2 cycle will be complete. So I believe now you are very well aware to the cyclic frequency. Let's try it again. Let's try to increase the frequency more. Instead of 4 pi, let's plot for the 6 pi and say 6 into pi. Add these plots. Now you can see, okay, this color is quite similar, so I'm going to plot again and again. Okay, now we have different color, and you can see the 6 pi plot, that is then green color. So this is the first cycle up to here, second cycle, and this is the third cycle. In 1 second it completes the 3 cycle. Let's plot alone, and you can see, okay, what happens generally. See, if I going to plot this 2 pi, it look likewise. If I plot 4 pi individually, again it look like same, again it look like same. Why? Because Abaqus try to keep the plot as same, but it changed the scale. Here you can see 6 pi in the 1 second. Okay, means 3 cycle within the 1 second. But if you plot this one, see, in 1 second it completes only 2 cycle. Here is the 1 second, the first cycle and second cycle, and if you plot this, again scale will be changed. In 1 second it going to be plot only 1 cycle. And if you want to limit, so you can go with that maximum and minimum value. Minimum is 0, maximum you want to plot for the 1 second, and now click on plot. So for the 1 second, similarly this one for the 1 second, and 6 pi plot for the 1 second. Okay, so you can limit this x and y, and now you can plot together also likewise. Okay, so hope this is very clear to you. And if you want to make a cost plot, what you can do in the same way, like going to copy it, and let's say cos 2 pi plot, and let edit it. See, as I told, this is the cos function and this is the sine function. So just alter the value, and let's again go to the plot, plugin, tool, amplitude plotter. So this is the cos plot, this is the sine plot, and I want to define the maximum value up to 1 second and plot. Now you can see the difference. Of course, this function is for the sine one and this is for the cos one. Okay. In the same, if you want to define the initial amplitude or something like that, say starting time, instead of 0 I have 0.2 second. So again, see, the second plot is a start from the 0.2 till the value is 0. Why? Because our initial amplitude is 0. But if you want to define some value, say 0.2 or 0.15 or whatever something. Now click on plot. So this will be shipped up to this point. Okay, let me move it a little bit here. Plot. So before this 0.2, the value will be 0.15, whatever I defined. Can we define sine and cos both? Of course you can define sine and cos both, like amplitude, periodic, but for that you need to optimize the function first, like what exactly you want to plot. Okay, you must have a mathematical approximation of your curve that you want to define. So circular frequency of maybe 4 pi, make sure the multiply or star symbol. So this is the 4 pi, starting time 0, 0, cos function and sine function, both function are 1 and 1. And let's plot the amplitude 5, and I believe, yeah, 1 and 1. I have to define something different value, 0.5 and 1, and now click on plot. So randomly I assign the values, and one more important point, as we have here n value, like it's not necessary to define the n value or an and bn only one time. You can define an, a1, a2, a3, similarly bn as b1, b2, b3 multiple time. Okay, so in the same I'm going to define like 0.2 and b value is 2, then 1 and b1 value is 0.5 likewise, and let's plot. So this type of curve you will get, but as I told, you need to optimize your curve first. Okay, do not define this value randomly, otherwise what you are going to generate you will don't know. So I believe you are very well aware to the periodic function now. Yeah, here we have some basic formulation, angular frequency 2 pi by t that we define. So what will happen every time if I define omega in term of 2 pi, so it become, assume that n is 1, 2 pi divided by t. Okay, so the angular value is always the function of current time and the total time. So in this way you have to define. Yeah, this is just one example. Circular frequency of 125 something. Okay, and here I given one example for the omega 1, omega 10, omega 20 cycle. So of course now you can define very easily. Here omega 1 cycle means 2 pi, omega value is 2 pi. Here omega is for the 10 cycle, not 10 pi. For the 10 cycle, 1 cycle equal to 2 pi. So 10 cycle equal to 20 pi. Similarly, for the 20 cycle, 20 into 2 pi, that's mean 40 pi. In this way you have to define. And of course, if you want to take a overview, like what are these values, you can take from here. You can take a snapshot of this screen also. This is the initial amplitude. I already explained, but here it will give you a overview. AN value from here, like 0, 1, 2, 3, 4, whatever you are going to define in this column, and B value, here the B value 1, 0, 0.5, and whatever you will define. So B1, B2, B3, in this way it will be. Starting time T0, if you don't have any starting time, just keep it 0. And initial amplitude, that is already defined here. Omega, that is the circular frequency, and that's all. So if you want, you can take a screenshot. That will be helpful to you to defining a periodic amplitude in future. So now go to the next one, that is the modulated. It's quite similar like periodic one, but here you have to define a periodic function, and here you have to define the modulated function for the signals. This is the just application. You may have modulated curve for the many of the applications. So again, A naught initial amplitude you have to define the A value and B value. Here we don't have B value, I'm sorry, because those are in the multiplication, not in the addition or subtraction. So A value you have to define, that is the starting amplitude. See, this is the initial amplitude, and the A is the starting amplitude, or simply we can say amplitude. Then starting time T0, and circular frequency, this is the circular frequency omega 1, and this is the circular frequency omega 2. So let me define this modulated curve in the abacus. I'm going to dismiss it. Let delete everything. Amplitude, go to the modulated, and as I told, initial amplitude, if you have anything, no, you cannot keep this amplitude as 0, otherwise what will happen, the all function become 0. How? See, this is the 0 initial amplitude, we already put at 0, and so 0 plus this will be 0, everything become 0. So I'm going to define as 1 starting time, 0 circular frequency of maybe 5 pi, that is say simply 5 pi, and here we can define 10 pi. Click on OK, and let's try to plot it. So just go to plugin, tools, and amplitude plotter, and this one plot. So in this way you will get a modulated plot, modulated curve. So this is important when you trying to define such signals, modulated signals. And I wanted to cover everything in the amplitude within the same video, but I believe this become very lengthy. So I am going to stop here, and I will try to explain this other amplitude in the next video. So keep active yourself for the second video, and I will surely update the video very soon. If you have any query or questions, you can put message on the comment section, or you can post in the Telegram and Facebook group. Link for the both groups are available in the video description. You are most welcome to join the knowledge sharing community, Simtex05. So thank you again.